Welcome back. This is the second episode of the Breakout Program It Yourself series in C++. Last time we set up the project, created the application class, and opened a GTK window. This time we'll receive and handle Keypress and key release events. We'll draw in the window using the Cairo graphics library. We'll set up our draw frame function to create and redraw each image frame, and draw a ball in the window. So without further ado, let's dive in. In GTK, as in pretty much every UI library, there are events that occur, so like a keyboard press event or a keyboard release event, a mouse motion event, mouse click event, and so forth. We want to connect up those events to call functions that handle those events. So in GTK, they're called signals, and we are going to connect up a function that handles that signal. First thing we need to do is tell it we want to receive those signals to our function. So let's go ahead and create constructor. And we're going to add the events GTK Keypress mask ORed with, this is a bitwise OR, GTK key release mask. So we want both the key press masks and the key release masks to be sent to our application. Then we need to connect up the signals to it. Signal key press event, connect. You've got to give it a reference to a parent object. So that would be this apps object. And then you give it the name of the function. And we'll talk about this last parameter in a minute. Let's go ahead and create the onKeyPress function. It has a special signature, and you can figure out what that is in CLion by just hovering over signal key pressed event. And it has this glib, signal proxy, Boolean, GTK event key pointer. So Boolean is the return value that your function needs to have, and GTK event pointer is the first parameter. In fact, it also shows here, slot prototype is a Boolean on my key press event, GTK event key pointer key event. So that's what we want to do for our onKeyPress function. So now we should get key press events. There we go. You get a key press message every time I press a key. Then to find out what key it is, it's event arrow key value. That'll give us some number that indicates which key is being pressed. So a lowercase a is a 97. A lowercase s is a 115. A capital S is an 83. And you get all the keys. So this is left shift, right shift, the left control, right control, the arrow keys, and so forth. You could go through and record all the numbers down and record them all for your keyboard, but that's already been done. So we can just add a switch statement and use the predefined values, GTK key left and right. So press the left arrow key, we see left arrow key is pressed, right arrow key is pressed. If I push the other keys, I still get the key press message, but it's detecting the right keys. Now let's talk about this false here. So what this means is whether it's going to call our event handler after the existing event handler. It turns out our window already has an event handler that handles keyboard presses. So when you press a key, it goes to that handler first by default. And if that key press gets handled by that event, it doesn't call any more functions. So if we change this to true, which is the default, by the way, or we can just leave it out and it'll default to true. Then when we press the keys, we don't get the event because the existing event handler is handling that key press, and then it's not calling the next function. See, the event handlers can return a true or false, meaning whether they handled the event or not. So if they didn't handle the event, it'll go on to the next event handler in the list. But if it did handle the event and returns true, then it won't go on to the next event handler because that event's already been handled. So there's a priority. So by setting this to false, what we're saying is don't call our event handler on key press after the existing, call it before the existing event handler. Call ours first. And then what we should be doing is returning whether or not we handle this key press. So if we handle a left arrow key press, then we should return true here, saying we handled that key press, so it doesn't keep going down the chain of key presses. And if we don't handle anything, then we should return false and allow those events to pass on to the next layer of event handlers. If you wanted to override the existing event handler, what you could do is add your own. So let's go ahead and change this back to true so that our event handler doesn't get called. I mean, it only gets called if the key press isn't handled by the existing event handler. But then the existing event handler can be overridden. All right, so we've overridden the existing event handler, and we'll just print out a message with the key press and the name of the function so we can tell which one is being called. And then in this case, we'll return true, meaning we handled the event. Now when I press the keys, you can see it's calling the onKeyPress event function, not the onKeyPress function. Now if I change this, let's close this. Now if we change this to say false, it's going to call the onKeyPress function after the existing onKeyPress event function. And in this case, since we're saying we didn't handle the event, it should be passed on to our keypress handler. And so you can see now it's calling both the onKeyPress event function and the onKeyPress function. And then we call false here. We press a key. You can see it's calling the onKeyPress function first. And since we're handling those keys and returning true, it doesn't call the default event handler. Now, if we press another key that we're not handling, like the up arrow key or the down arrow key, then it calls both functions again. Okay, so the bottom line is you want to set this to false, have it call your event handler first, and then you don't have to override the existing function. We can just leave this out. Just remember you got to do false here. And then return true on the cases where you handle the event, just like this. To add key release events, which are separate from key press events, press is when you push the key down, release is when you let it up, we need to add a separate event handler. So let's do that. All right, so we press a key, it says pressed, and when you release the key, it says release. So I pressed and released it. And if you press and hold the key, it's going to say pressed, then there's a long delay, well, longer delay, and then there's a short delay, and it calls the key press event over and over and over again. That's the key repeat. So again, it's press, long delay, and then press, repeat, 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 short delay. So when I press and hold the key down, what you'll see is pressed will be called once, and then a whole bunch of times in succession, and when I finally let go, it'll be released. And then I'll let go and it's released. So you saw that it had a long delay after the first press, and then a bunch of repeats followed by finally a release. So what we want to do is create an image that we can then show in our window, and then we draw on that image and show that image frame in our window over and over and over again. So those will be the frames. So in order to do that, what we're going to do is create an image and draw on it with a library called Cairo, and then show the image. So let's go ahead and do that. So our image is this GTK image, and then it's backed by a GTK pix buff that actually holds the image data. And then we create this image surface that we're going to draw on, a Cairo image surface. And then the context allows us to issue the drawing commands. So these all work together like this. So first we create an image surface, then we tie the context, the Cairo context, to that surface so that we can issue the drawing commands through Cairo on that given context. And then we create a pix buff directly from the image surface data. And this is just an intermediate place so that we can transfer the image data over to our GTK image. And the way we do that is we just say gimage.set and then give it the name of the pic. And that will store the image data into the GTK image. That's how we actually show it in the frame. Now I haven't defined width and height yet, so let's go ahead and do that. Then we need to add the gimage to our window and show all the widgets or elements in the window. All right, there's our window. It's 1,000 by 1,000. There's nothing in it. So let's go ahead and draw something in it. But we don't want to just draw here in our constructor. We actually want to create a draw frame function. So let's go ahead and do that. For now, we'll just clear the background with some background color, which we need to define. This is a Cairo color stop. It's just a simple struct. It's got some offset and then a red, green, blue value and an alpha value. So you can just ignore the offset for now, just set it to 0, and then set the RGB values to something, and then the alpha value can be 1. So these are 0 to 1.0, 1.0 being white, well, or maximum red, green, and blue. So if they were all 1, then it would be white. So we're going to set the color to that, and then we'll paint it, and then we need to update the image. So we'll set the pic again. But we're not yet calling draw frame, so let's call it one time in our constructor. Okay, now you can see it's a dark gray because we set the color to 0.1.1.1 for RGB. Now one thing you're going to notice is when you do it this way, the red channel and the blue channel are flipped because we're drawing with Cairo onto this pix buff. It's backwards. So the bottom line is, if you want to see a red, even though this is red, green, and blue, let's say we wanted to see a blue background right now with this 1.0 in the blue space and us setting the color to, oh, this is wrong, red, green, and blue. With us setting the blue value, we should see a blue screen, but we're actually going to see a red screen. Because again, we're just accessing the data directly and they can be stored in different formats. So if you find this problem, just recognize you just want to flip it. So you can either flip it here or you can flip it in the color. So let's just flip it here, then we can put it into our color the right way. Blue, green, red. So now it's a blue. Now when I come in here and change my color to red, we should see red. And we see red. And then of course, for completeness, we'll do green. There's your green. Or white. Okay? So now we have a draw frame function. Now what we want to do is call that draw frame function over and over and over again. In fact, we want to call it on a clock so that we render the frames regularly as fast as we can, or at 60 frames per second. So let's go ahead and add, what we'll do is we'll add a timeout signal. And what that'll do is it'll basically just call our function at regular intervals. So I'm going to set a frame rate target, FPS, and we'll say we want it to run at 60 frames per second. And then what we'll do is create what's called a glib signal timeout. So we're creating this signal timeout. We're going to connect to a timeout signal that we're going to create. We're going to create a pointer to a member function. The name of the member function is the one we already have, draw frame, and then we're going to issue that command 1 over the frame rate times 1,000, because it wants the numbers in milliseconds. That's our interval, milliseconds. Okay, then we don't have to call draw frame here. And we don't have to set the pick at all. That'll happen in our draw frame function. So let's try that. So now it's drawing our frame every 60th of a second. And to make sure it's really doing that, we'll just add a message real quick. So there it is. It's calling draw frame over and over and over again. Now at this point, all we have to do is draw something on our frame. So just to give you an idea of what you can do, let's just draw a line. So think of this like a plotter. We're going to set the color and the line width and the parameters of the pen we're about to use. Then we're going to move to some location on the screen, and then we're going to issue a draw command. And then once we're done issuing a bunch of draw commands, then we say stroke or fill, and then we'll actually paint those commands into some final image on the pix buff on the image. So here we're setting the color. We have R, G, B, and then alpha. We set the line width, 3. Then we're going to move to 100 pixels toward the right, 100 pixels down, because 0, 0 is in the top left. And then we're going to draw a line to coordinates 200 over, 300 down. And then stroke actually draws the line. So there's our green line. We start at 100 over, 100 down, and we move to 200 over, 300 down. And then we draw a line between those 2 points. So let's draw a ball. First, let's change the ugly white background back to something more appealing. Now instead of drawing a line, we'll draw an arc. Not a boat, an arc, a mathematical arc. So instead of a line 2, we're going to do an arc. And the parameters are x center, y center, radius, and then the start angle of the arc and the end angle of the arc. Since we want a full circle, we're going to go from 0 to 2 pi. And then fill preserve is going to fill it in, and then we'll stroke the outline. Okay, there's our green ball. Nice. Now what we really want to do is create a ball class and let it draw itself. So we'll create a ball class. Move this into the draw function. And we'll create a ball object. And have it draw the ball. And there's our ball. Now let's allow the ball class to actually have parameters that we can change. So we'll give it a center point and a radius and a color and a line width, and then we'll use those to draw it. Red, green, blue, alpha, line width, center, 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 center. Now, in this case, I had these flipped, so let's go ahead and change them around the way that we had discussed. There's our ball at 0, 0, because 0, 0 is the default position, so we can change that when we create the ball. Now it's at 100, 100. So now we've got a ball drawn. The other thing we'd like to do is change the coordinate system to make our life a little bit easier. And Cairo gives you a nice way to do that. That's built in. You can just use a transformation matrix and set the current matrix to that transformation matrix. So if you look at the parameters for a Cairo matrix, you see it has XX, YX, XY, YY, X0, and Y0. So those are for the 2D transformation matrix. So XX is this value in the matrix, then XY, then X0 would be your X translation or shift in X, offset, whatever you want to call it, YX, YY, and Y0. So the ones we care about are these main diagonals, XX and YX. Those would be our scale factors. So what we want to do is we want our transformation matrix to look like this. This way, X is still the original scale. Y gets inverted. So instead of counting up as it moves down the screen, we'll count up as we move up the screen, which is more like a typical mathematical graph. And then we'll offset it 500 and 500 because those are the width and the height. So actually what we want to do is change it to width over 2 and height over 2. So now in our coordinate system, what did I miss here? It wants a double. Okay. So now in our coordinate system, 0, 0 will be in the middle of our view, and it will count up to 500 at the top and to the right to 500 on the right. So let's just let our ball be back at 0, 0, and it should draw it right in the middle of our screen. And there it is, right in the middle. So if we want to move it, let's move it up to 250. So change our Y here to 250, and you'll see it's up instead of down now. And there it is. It's 3/4 of the way up. So to make our lives easier, instead of declaring a ball and then setting all the values like this, let's do the right thing and create a constructor that does it for us. Then we can just create the ball object and give it the X and Y center parameter coordinates and the radius. So now in our app, we can say ball and give it 0, 0, and we'll give it a radius of, I don't know what our radius is, 10. There it is, 0, 0 with a radius of 10. And whenever you create a specific constructor, if you want your default constructor there, you have to redeclare it. In case you're wondering about this, let's say in our, oh, I'm going to the wrong place. All right, let's say that instead of calling this, we don't initialize the ball. And let's say we don't have a default constructor. So the question is, where does the ball get constructed? Well, it would get constructed here with the default constructor. But since we have a specific constructor, the default constructor is no longer created by the compiler. So we end up getting an error. It says no matching function for call to ball, which is the default constructor. Now, if we didn't have this, like we did before, that would be fine. It would automatically create the default constructor. But since we declared one of our own, the compiler says, well, I don't know what you want to do, so I'm not going to create anything for you. So it doesn't create the default constructor anymore. So we have to explicitly tell the compiler that we still want a default constructor, and it will initialize all the values like we have here. So in this case, that's fine. And then we don't get the error anymore. Except for this error, no return statement in our draw function. Yeah, let's just return true. Okay. So let's put it back the way it was. And there's our ball. And now, of course, we can set the Y value here. And now he's at 250. So that's more convenient.